Good evening, everyone. Is the mic on? Good. Thank you for coming. As Eduardo pointed out, I'm Hannah Hobbs. Many of you do know me. I've been helping out with this ANFA conference. I want to first and foremost thank my Masters of Architecture Thesis Committee for all of their feedback, time, expertise, and above all support, specifically Kurt Hunker, for working with me on the study for 2+ years, for guiding me when I was challenged or lost, and for his unwavering support, and to Dr. Demircay, who was my thesis studio instructor, constantly asking questions to ensure I knew what I was talking about. Second, I want to thank ANFA for this honored opportunity to be selected among the few to present at their second international conference, and for their continued support of my future. Also, can we all please recognize the volunteers who have been tremendously helpful, not only today, but I know in the next 2 days for this conference. And to the ANFA board members and the advisory council for putting this together, and ANFA in general. Okay, Eduardo. Here's a quick overview of what I'll cover in this presentation. It's basically my thesis study that I just graduated with. Yay! As often stated, architecture is the balance between art and science. This study was a good example of this balance, as it explored the relationship between architecture and neuroscience by applying the scientific method to test preference of different architectural interior forms derived from the advancements of technology utilized in today's design process. The architecture studied were of 4 out of the 15 and counting built Maggie centers located around the United Kingdom. Maggie centers are community cancer centers for people diagnosed with cancer and their loved ones, and more specifically, they are each designed by internationally acclaimed architects, whom were all given the same exact architectural brief. I will discuss more on this later. This study tackled 3 major components. 1, develop a scientific study to understand contour preference within architecture. 2, design and build a semi-immersive virtual environment on a limited budget to conduct this study. And 3, compare and contrast previous contoured-focused studies tested at a visually small scale to a near 1-to-1 scale, like this study. Based on previous architectonic and neuroscientific studies showing a statistical significance of preference for and less amygdala activation of curved contoured objects versus sharp-angled contoured objects, this study postulated preference to be higher for curved architectural interior environments over other interior environments comprised of different geometries. More specifically, the other geometries are comprised of acute angles, right angles, and a mix of curves and right angles. I'll explain the different contour categories in more detail when I discuss the Maggie centers. The problem first came to me in 3 parts. First, in our current modern society, people spend a majority of their lives indoors, whether at home or at work, and let's not forget we even get our exercise indoors. Studies have shown that enriched environments can change our brains. In the late 1940s, psychologist Donald Hebb noticed improvements in behavior from the rats he brought home with him over the ones that stayed in his austere lab. And third, a more personal example and the driving factor for the study. All too often had I sat on studio final reviews where students had designed buildings comprised of curved surfaces and are often criticized with the common question of, why is the wall curved instead of straight? I recognize the juries are trying to understand the reasoning for the curvy buildings in hopes that just because the technology is there allowing students to design these buildings, that alone is not the rationale. All of this gave impetus to study the effects of contours within architecture has on us, with the specific goal to either support for or against why one should design a building comprised of curved or straight walls. A portion of the literature review for this study discussed both neuroscientific and architectonic studies conducted to understand if and how people prefer different contours. The top 3 are neuroscientific studies and were the original support to examine curvature in architecture by establishing the need to understand how contours, both curved and sharp, affect our brain. These neuroscientific studies gave precedent not only to this study, but for the bottom 2 architectonic studies shown here. Barrenetta's 2006 study examined everyday objects with a neutral valence and saw people preferred curved objects. They then took this to see where in the brain activation occurred to hopefully understand why the preference for curves over sharp angles. Barr continued the work with other colleagues to establish if positive or negative valence objects had an effect. The only noticeable difference was found in the positive valence objects. The neuroscientific studies examined gave precedent for the need to study contours in architecture. These two studies reviewed not only supported the hypothesis established from the previous studies, but also helped define the methodology used in the study in three major ways. One, the removal of color and extraneous furniture that could lead to a potential bias, as in the study on the left. Two, utilizing bipolar adjectives, as found in the doctoral thesis on the right. And the utilization of a semi-immersive virtual environment. As mentioned earlier, this study focused on 4 Maggie centers located around the United Kingdom. An interesting fact about Maggie centers is that all buildings designed are commissioned by internationally acclaimed architects whom were all given the same exact architectural brief, program and scale among others, though their forms varied significantly. After reviewing the 15 centers shown here, 4 contour categories emerged, as did the chosen buildings. I will discuss the 4 next, but before I do, I want to point out to the left diagram. I want to point out to the left map, the diagram shows the location of all the current Maggie centers around the UK and labeled based on the decided contour category for each of the buildings. The few with the question marks had little to no information except that it was in the works. As you can see, the thumbnail images on the right are mostly of the exterior. I point this out because when looking at the building in its relative entirety, such as this, it becomes more of an object than an experience. And this study focused on the experiential. Typically, case study analysis usually involves investigating a similar typology or a type of architecture to the design program intended. For example, a healthcare facility, a mixed-use or urban building, an urban mixed-use building or school. However, the focus of the building selection for this study was entirely on what the resultant form was, as the program was already determined when choosing Maggie centers. The process of categorizing each center was similar to what was shown here, looking at all the available plan sections, elevations, and photographs to distinguish contour majority. These are the 4 chosen buildings with simple contour emphasis overlaid. The swooping upper level of Southwest Wales, the curved windows opening in the rectilinear interiors of Aberdeen, the abundance of right angles in Cheltenham, and the triangular windows in Fife. Here, under each category, the left image is the actual building and the right image is a frame from the video walkthrough from this study's experiment. All buildings were modeled using Rhino, a 3D modeling tool used by architects and designers, based off of the same available plan sections, elevations, etc., used to determine the contour category. An important note is that some slight alterations occurred to enhance the contour category for these buildings. For the curved, the chamfering of edges and the removal of some windows and elongating of others to accentuate curvature. The mixed was similar to curved with the chamfering of edges. Rectilinear was fine as it was. And the only change made to the angled building was the center wall, which was actually curved, though angled in this experiment. In addition to these changes, it was important to remove all material textures and extraneous furniture, such as chairs, rugs, shown in the mixed photograph. I should state now that each participant experienced all 4 models in a randomly selected order for 30 seconds. I'll get a little bit more into the experiment. In order to conduct this study at an immersive level, I needed to A, either utilize an existing immersive technology such as the Star Cave, as many of you just experienced, or B, build one. Due to cost and other constraints, it was not feasible to use current technology, so my classmate Kevin Sullivan, who's one of our volunteers today, this weekend, convinced me we could build one on the cheap. So that's exactly what we did. While the last slide depicted details of the immersive technology, this diagram explains the KVET and location of participants and myself when conducting the experiment. For those curious how I came about the name KVET, CAVE is an existing acronym standing for Cave Automatic Virtual Environment. And while I did not come up with that, KVET, on the other hand, played off of cave, but it's little, so it's a KVET. The original intent of this study was to conduct one immersive experiment. But as the study went on, 3 more were conducted to ensure confidence in the findings, for a total of 4 experiments. Boop. There we go. While the 4 can be grouped into 2 types of experiments, immersive experiments and 3-second studies, they each developed individually. This presentation will only discuss findings from the immersive experiment, for today's session is about architecture, technology, and scientific studies, i.e. how architects can do studies. As this was a preference study, the definition of preference is a must. For the immersive studies, preference was defined by using 7 sets of bipolar adjectives with an added neutral between each one. Here's the form each participant filled out to determine their preference for each building after watching the individual walkthrough videos. For analysis, the words on the left were given a score of 3 for positive preference, neutral is given a score of 2, and the words on the right were given a score of 1 for negative preference. Therefore, the higher the score, the higher the preference rating. 80 subjects were tested in the first experiment, and after preliminary analysis of the first experiment, there were some concerns regarding speed and timing across the videos. So I was asked to fix the speed of the walkthrough videos so that they all were the same, and test another 20 subjects. This slide shows the difference in velocity between each experiment. Students, faculty, and staff from New School of Architecture and Design were approached to participate in this study. The forms on the right are the background questionnaire each participant filled out. This was used to analyze the results across the various demographics at the school. Also, the reason for the 2 different forms is that the top was for students and the bottom for faculty and staff to distinguish education level. Now for the fun part, results. Most of the graphs presented in this section represent data collected from the immersive experiment. As hypothesized, preference was higher for the curved environment. Furthermore, as the amount of curvature decreased and angles increased, the data shows preference drops. As mentioned earlier, there was a concern for varying speeds across all videos. The results from the second study show that an overall increase in preference for curved, mixed, and rectilinear buildings compared to the first study, while there is a decrease in preference for angled buildings compared to the first study. After conducting an analysis of variance, or ANOVA, I can say there is no statistical difference of preference rating between the first and second experiment for curved, mixed, and angled. However, I cannot say that is true for the rectilinear, for there is a statistical difference between the 2 immersive experiments. Here we are looking at each bipolar adjective sets across all contour categories to understand preference rating. Notice that the participants viewed the curved building with a higher preference, but for all but the exciting, depressing word set. Also, it is interesting how as exciting increases, relaxing decreases. This is to say that excitement is not always good. Here I have parsed the data by different demographics. Some key points I want to make. Gender. Unlike the literature I reviewed, there is a difference in gender preference. The females preferred curves to angles. Designer versus non-designers. The results show that there is a higher preference for curved and rectilinear buildings by designers than non-designers. Graduates versus undergraduates. This graph shows undergraduate students prefer more unconventional building designs over the rectilinear buildings the graduate students prefer. This could be due to the excitability of the undergrads. And years in practice. Here we can see that years in practice does not affect higher preference for the curved building. Although look at those in the 6 to 9 years in the architecture design field, they preferred the curved, mixed, and angled building over the rectilinear one. With that said, this study presented itself with the opportunity for further studies, namely utilizing fully immersive virtual environments, testing the actual built Maggie centers located around the United Kingdom, maybe, and more. Test more. As I mentioned in the beginning of this presentation, this study tackled 3 major components. Develop a scientific study to understand contour preference within architecture, fine. Design and build a semi-immersive virtual environment on a limited budget to test contours within architecture at a near 1-to-1 scale, okay. Compare and contrast previous contoured focus studies to test at a visually small scale to a near 1-to-1 scale of this study. Great. However, while I did do all of these to the best of my ability in the given time frame, the most important conclusion I can draw from this study was twofold: teamwork and perseverance. From the onset of wanting to do a brain study for my Master's of Architecture thesis, wherever I looked, there was a professor, a classmate, a stranger, and even family encouraging me, guiding me, and questioning me. I would not have been able to do this without any of them, for all of them made a difference. Okay. Thank you.